Hi everyone! So today we're going to solve another LeetCode problem, which is meeting rooms 2. And the problem is, given an array of meeting time intervals where intervals I is equal to start I and I, return the minimum number of conference rooms required. For this problem, we can relate this to a real-world scenario wherein let us say you are a meeting room administrator and your task is to secure conference rooms for meetings all throughout the day. And there are at least two ways to solve this problem. The first one is using priority queues, and the other one is using the two-pointer technique. On this video, we will focus on the two-pointer solution, so let's go ahead and see how we can solve this. In order for us to solve this using the two-pointer technique, we have to create two array variables for start and end time, then sort them individually. And while we're doing this, you might be concerned that the pairing of the start and end time will be lost. But the reality is, every time we encounter an end time, it means that at least one meeting has ended. We don't really care which meeting has ended. All we need to know is a meeting has ended, thus we can reuse that room. So consider this sorted start time and end time here, which is based on the example one. So start time, when you sort it, we will have 0 first, 5, and 15. And when it comes to the end time, as you can see, the sorted end time is not matching anymore with the given input. So 30 can be found here, 10 is here, and 20 is here. And that's where you might think that we may be messing up with the input. But let's see how our algorithm will work to prove that it is fine to treat them individually. First off, before we proceed, let us consider these two facts on this problem. First is that whenever there is an end meeting, there will always be a start meeting. And that is true because we will always have an equal length of start time and end time. And the second fact is that a start time is always less than the end time. So let us see it in action by formally traversing the start time and end time arrays here and figure out what is the minimum number of rooms we need for these given intervals. We will be needing these variables here, start pointer, end pointer, and room count, and all of these variables will start with 0. Now, as we traverse the start time, the array start time, we will always assume that we have to create a new room for it. It is like we're staging a room for it, but we still have to finalize it. And the way for us to know if we really have to create a new room is to compare the current start time versus the current end time. If the current start time is greater than or equal to the current end time, then we cancel out that count. Because if a start time is greater than or equal to end time, that means that a meeting has just ended and thus we don't have to create another room. And how can we be sure that a meeting has just ended? By just checking if start time is greater than or equal to end time. And that is because of the second fact that we put here, that a start time is always less than the end time. And by the way, our condition is like this, greater than or equal. It's because an example of 9, 10, and 10, 12 doesn't mean that they overlap. So for this example, we just need one room. Now let's continue traversing start time and end time. And so for these three variables that we have here, they're all initialized to 0. That means that start pointer is pointing to 0 and the end pointer is pointing to 10. Now, as what we have explained a while ago, every time that we encounter a start time, we're gonna assume that we have to create a new room for it, right? So let's increment room count to 1. And then we ask, is 0 greater than or equal to 10? And the answer is false. So the end pointer will be retained as 0 and the start pointer will become 1. Now start pointer is pointing to 5 and this is a new start time. Again, we're gonna assume that we have to create a new room for it. So let's increment room count to 2. And we ask, is 5 greater than or equal to 10? And again, it is false. So we retain the end pointer to 0 and we increment start pointer to 2. And in a real world scenario, what we just did is like we're asking, is there a meeting that ended at 5? And by looking here on the end time array, the earliest meeting that will end is 10. So that means that we really have to create a new room for the start time 5, right? Now our start pointer is pointing to 15 and this is a new start time. So again, we're gonna assume that we have to create a new room for it. So let's increment room count to 3. Then we ask, is 15 greater than or equal to 10? And this time the answer is true. What does that mean? That means that we have to cancel out the assumption that we have to create a new room for the meeting that starts at 15. Because upon checking, we found out that there was a meeting that ended at 10, right? So basically, we don't have to create a new room and we can simply reuse the room that we created for 10. So this tree here will become 2. And also this time, we have to increment our end pointer to 1 because the meeting at 10 is already done. Then we simply increment the start pointer to 3. And as there's no more start time at index 3, that is when our loop will end. And finally, we just return the final count of room count as a result, which is 2, and it is correct based on the expected output here. The time complexity of this solution is O of n log n because of the sorting, and the space complexity is big O of n, where n is the sum of the length of start time and end time arrays. Now let's go ahead and code the solution. So first off, I'm going to create a variable length, which is equal to the length of the 2D array intervals. This is not required, but I prefer to do this so that it's easier for me to reference the length. And next, I'm going to create the array variables for start time and end time. This one will have a length of length, and end time will also have the same length. So now that I have these variables, the next step is I'm going to populate them. So int I is less than length I plus plus. Then I'm going to populate the start time with the first column of the intervals. So intervals I and 0. And then the end time will be the second column from the intervals to the array. Now that I have it populated, the next step is I'm gonna sort the start time and end time. So let's call arrays that sort start time and also arrays that sort end time. And now that start time and end time are sorted, I'm gonna create the variables that we were debugging a while ago. So int start pointer, which will be initialized to 0. The end pointer will also be initialized to 0. And the room count, which is also 0. Now I'm gonna traverse the start time, which start pointer is less than to length. So as per our explanation a while ago, every time that I encounter a new start time, I'm gonna assume that I have to create a new room, right? So room count here will always be incremented, but I have to double check if I really have to do that. So if start time start pointer is greater than or equal to end time end pointer, then what I'm going to do is I'm going to reduce the room count and I'm going to increment the end pointer. And otherwise, I'll just simply keep on moving on the start time. And lastly, I will just return the room count. So let's go ahead and submit this solution. So as you can see, it's accepted, and the runtime is 4 ms faster than 95.69%. And yeah, that's all for this problem. And let's meet again on the next LeetCode challenge.